Hi everyone, today I'm going to talk about derivatives and differentiation. So first of all, we have to know what derivative means. The basic definition is how fast a function is changing at any instant. This is the important part. This definition would be familiar because we know that the definition of a slope is the rate of change of a linear equation or linear function. So if there's a linear graph like this, we know that the slope equals to delta x over delta y, right? This is the rate of change of this equation. So why we learn derivatives is because you want to know the rate of change of not only linear, but also for nonlinear equation. For example, for nonlinear graphs like this, at every point the rate of change is different. So if you see here, in this part, for a small increase in x, y decreases by a bigger amount than for here. For a larger amount of change in x, the change in y is smaller. So this means that the rate of change at the points here is higher, is faster than the rate of change in here. So we want to use the derivatives to calculate the instant rate of changes at each point. So how? How do we do this? How do we calculate the derivatives? First, we can do this by using the definition or using the difference quotient, which is these equations. These equations you can memorize or you can also understand. It's easier to understand, I guess, because let's see an example here. If we have a function like this is point A, and this is point B. Let's first think about the average rate of change between these 2 points. Then it would be the change in x over change in y, right? Which is b minus a over fb minus fa. Which is, it also can be seen as the slope of this line, the line that connects FB and FA. So what we can know from this is that now if we want to find out, if this point is C, if we want to find out the instant rate of change on this specific point C, we can find out the slope of this line, which is the tangent line that passes through point FC. So now the question is, then, how do we calculate the slope of the tangent line? Now we know that the instantaneous rate of change equals the slope of tangent line. So how do we calculate this? We can use this equation to calculate this. Let's look at this graph again. Let's say that B gets smaller and A gets larger. So let's say this point is A and this point is B. Then the average rate would be the slope of this line. If they become more closer, so A is here and B is here, the average rate of change would be the slope of this line. So if as B and A both approach C closer and closer, the slope of the line that connects them becomes closer and closer to the slope of tangent line of C, right? As these two points become closer and closer to each other, it will eventually meet at point C, and then we will be able to get a slope of a tangent line that only passes through point C. So if you want to find the slope of the tangent line at point C, this can be written as this. It's the same. We get the rate of change, which is the change in x over change in y, which we can write as x minus c and fx minus fc. So it's like in such graph, that's c and that's x. Then we want to make x approach c so that we can calculate the tangent line, the slope of the tangent line. So we limit x approaches c. So this, by using this equation, we can calculate the instantaneous rate of change of this function at point c. Another way of writing this equation is, let's say x minus c equals delta x. Then if we substitute this into this equation, we can get the derivative of y with respect to x, which is limit approaches to 0, fx minus fx minus delta x over delta x. And this can also be written as this. It's the same because this equation shows the case where delta x approaches from the left. So this is delta x. In this case is where this is x and this changes delta x. So the delta x approaches from the right. It's the same thing. Easy, okay? So now, since we know the basic definition of a derivative, we want to know the conditions where derivatives does not exist. This is important because it commonly comes out in MCQs of the AP test. So there are three basic conditions that we need to remember. First, derivatives doesn't exist if there are sharp points or cusp at x equals c. For example, in a function like this, well, these are both straight lines, and this is point c. We can see that at this point, we have a sharp point. If a function is not smooth, it does not have derivatives at that point. Well, if you want to calculate the derivative at, let's say, 0 for this function, it's here. You can just calculate the slope at this point, or the slope of this graph. Yes, you can calculate it. And then let's say this point is 5. The derivative of x at 5 is the slope of this graph, or at this point, right? You can calculate it, but at c, you can't. Why? Because I said that derivatives means the rate of change at a point. But let's see, at this point, can we calculate the rate of change? No, right? That's why the derivative doesn't exist. Okay? Then the next condition is when a function is discontinuous at x equals c, derivatives doesn't exist. For example, if we have a function like this, derivatives doesn't exist at this point. This is kind of more obvious. Because these 2 points are not connected, we can't calculate the rate of change. The rate of change can be calculated by the slope of the tangent. For both these two cases, at these points C, we can't draw a tangent line at these 2 points. That's why it doesn't exist. Lastly, derivatives doesn't exist where tangent line at x equals c is vertical. For example, here we have a arctangent graph. at point 0, if we draw a tangent line, it would be x equals 0. Or slope doesn't exist. Or maybe it's infinite. We just said when we calculate derivatives, we are trying to get the slope of a tangent line. But here, the slope doesn't exist. And that's why, in this case also, the derivatives doesn't exist. You should remember this. You should remember one important thing here. If a function is discontinuous, then it is not differentiable. But it doesn't mean that if a function is continuous, it's differentiable. No. This is not true because right here, this shows the perfect counter example. It's continuous, but since it's sharp, it's not differentiable. So you shouldn't be tricked by these word questions saying that a continuous function is differentiable. It's not. It's not 100%.